Hi, this is Mr. Max. I am doing paper 2 for 2026, the mock examination for Erongo region. So this is for the AS level learners. Okay, I am going to just highlight just a few important information here under the instruction and information to learners. All right, very important that you do go through it. There is a list of formula and notations that is attached obviously in the question paper. Then the one that I perhaps have to make a little bit mention more is this second last bullet point, which indicates that if the degree of accuracy is not specified in the question, and if the question is not exact, give the answer to three significant figures. Give answers for angle sizes to one decimal place, but angles in radians you give to three significant figures unless a different level of accuracy is specified in the question. Now, there will be a lot of times where in the paper you would see that you are supposed to give your answers as exact values. That means you have to give them either in terms of pi or in terms of, in radicals, whether it's a square root of 3 or, in that kind of stuff, or fractions. So read the questions very carefully as you attempt to do the questions. Right, I will be posting a link where you can download the papers on my Google Classroom, and also with the worked out solution that I'm now doing with you over here. Right, the very first question. So I'll be going back and forth, especially when I realize there are certain formula that you need to use in order to assist you to do a certain question. So this is an absolute value equation where you have the absolute value on both sides. There are many ways you can do this. One of the ways is either you square both sides, okay, you square this, and also remember that you are pressed for time. Please do not make obvious mistakes. If you do all of this squaring here, well, you're going to have a 9x square over here. I hope that you should remember how you do binomial, expansion. 3x times 1, 3x times 2 of them. This will be 6x because you have 3x times 1 plus another 3x times 1. And then at the end of the day, you will have a 1 here because 1 will square itself. So the first term, 3x all squared, is 9x squared. The last term, 1 squared, is 1. And then you take double of 3x times 1. That double of that, 2 times 3x times 1 is just 6x. So I'm going to apply the same over here. Square the first term, that is 4x squared. Then double 2 times negative 5, that's negative 10. And double of negative 10, that's obviously negative 20x. And then you square the last term. Anything you square obviously will be positive, and that's what you get over there. So let's just move everything to the left. So 9x squared, you're going to subtract the 4x squared, and then you are going to have that 6x, and then you're going to bring its cousin. That means you are going to be adding the 20x whenever you do that on both sides. You have a plus 1 then, and then obviously that 25, you will be subtracting that 25. So at the end of the day, you are going to be left with a scenario where you have 5x squared plus 26x minus 24, okay, which you can solve in order for you to find your solutions. And your solutions, you can use the quadratic equation formula. Perhaps I can just write that over here. So x is going to be minus the value of b, minus the value of b, obviously in this case is minus 26. So you have a 26 over here. You have plus or minus the square root of that positive 26 rather, all squared. Then you minus 4 times the value of a, which is 5, times the value of c, which is negative 24. All right, all all of this stuff comes under the square root, and then you would be dividing all of this, you would be dividing by 2a. Okay, so the value of a happens to be 5. So in this particular case, you would be identifying from here what is your value of a being 5, b being 26, and lastly c being negative 24. And then you obviously substitute it into the quadratic equation formula, which you will also find, at the list of notations. Right, so you will have two solutions. One will be x is equal to negative 6. So I'm going to be jumping sometimes to answers that I think are obvious for you to find, since there are quite a number of questions that we'll have to do. Okay, so those are the two solutions. The question is asking for you to solve the equation, right? Alternatively, you can obviously do the method of taking, I just have to make it smaller for you to see. So you obviously have 3x plus 1. So one of your solutions could be 3x plus 1 is equal to, well, then you have a negative, okay, very important, or you can just say 2x minus 5. That will be 1. The other one will be that 3x plus 1. Well, that will be like negative 2x minus 5. Think of it as moving from a certain distance in opposite directions. So if you were to solve these equations, you are also going to get the same answers like on top. So again, I'll just simplify it a little bit. So this is going to be 3x minus 2x is equal to negative 5 minus 1. So you can see here, x is equal to negative 6, which is something that we already determined from our solution. Okay, it's over here. Right, so just bear with me. This is going to act up a little bit. And then obviously the last one, you're going to be saying, I'm just trying to force the idea. You're going to have, now you're going to have 3x here. Now remember, this is going to be a minus 2x. So when you bring it over, it's going to be a positive 2x rather. So it's going to be a positive 2x if you bring it over. And then you have a negative and a negative, that is a 5 here. Taking this negative or this positive term becomes a minus. So you have got 3x plus that is 5x. Okay, let's just see, why did I say minus 4? But it's supposed to be minus 1. Okay, minus 1. So moving of terms. So you have got 5x over here is equal to 4. And clearly, if you divide both sides by 5, you would see that, of course, in the exam, you're not going to write in this margin. You'll see that the value of x is equal to 4 over 5. So we already had the solutions to these questions from using the other method, but no harm, no foul in whatever method you prefer. Okay, to solve the equation. Now there's a hence part, and hence indicate that whatever you have done in part A, you're supposed to use it. So I'm just going to write the equation in part A. In part A, the equation, well, the equation was the absolute value of 3x, is it, plus 1, which is equal to 2x minus 5. And if you compare these two equations, you'll see that where there is a x, there is a cot x, right? So that means you must now make a deduction and arrive that, well, x is supposed to equal to cot x, cot theta. That's what you need to understand. Right, another thing that is important is that you are told that theta, the angle, is an acute angle. How do I know this? Because the angle is between 0 and half pi radians, which is like 0 and 90 degrees. Okay, so since you have got two answers to compare the x values, you have negative 6 and obviously the other one is 4 over 5, it most probably mean that you will be disregarding one of those questions. So let me just write then, what do we have? We have cot of theta, which equals to one instance negative 6, or cot of theta, which will equal to 4 over 5. Now, remember, cotangent is actually, tangent. So when you switch, this becomes the tangent of theta, which is going to mean that you're also going to switch this one. That's going to be 1 over 6, right? Tangent is negative in the second quadrant and also in the fourth quadrant in your cast diagram. So this one is outside of the domain. We're not going to, work this out. So we are going to reject this particular one. So what we definitely will be working with is this one over here, cotangent hinge to tangent, and then you switch the numbers around because these are reciprocals of each other. And then they are asking you to find that. Again, make sure your calculator is in radian mode, and then you're supposed to give your answer to 3 significant figures. So let's grab the calculator and see what value are we getting. As you can see, my calculator is already in radian mode, so I'm going to have arctan for the inverse tangent of 5 over 4, right? Okay, and if you have that, you hit enter. You see, we get a value there. So let's just capture that, and let me just paste it somewhere um, here for you to see. Okay, sometimes it's necessary where we probably look and say, look right down and then do the rounding accordingly. So to 3SF, it's going to be 0.896. So that's 0.896 radians. And that is the solution to this particular question. Okay, right. So just make sure that, again, as I said, you show most of your working, then you would not have an issue as far as that is concerned. Just gonna highlight this in yellow so that you can see what my final answer is. We are not supposed to be looking for where your solutions are, okay? Please make sure that you indicate to the examiner, all right, as you prepare towards the end of the year, so for us to know what is it that the answer is. So this is a very important deduction, like arriving at that conclusion where x is equal to cot theta using the values of x from before, looking at how similar these two equations are. Right, that brings me to the second question. This question says you're supposed to show that x minus 3 is a factor of the function f of x, which is equal to 6x cubed minus 23x squared plus 16x minus 3. Now to do that, we borrow something from the remainder theorem, and the remainder theorem basically says that if you were to say x minus 3, which is equal to 0, right, then therefore x is equal to 3. And if you were to substitute this 3 into the function, so that's like f of 3, your output, if it's 0, then it means that that x minus 3 is a factor of that. There's no remainder. Okay, so I'm just going to do that. So everywhere where I have to substitute the x, you see I'm putting my brackets, and then you go ahead and you put the value of x, which so happens to be 3. Okay, so, and then, well, when you do that, when you are inputting f of 3 into the function, you'll see that you get 0. Then obviously you can say then x minus 3 is a factor of f of x. You can also say that. All right, we know exactly what it means. All right, so that is the deduction conclusion I make because I've been using the remainder theorem to prove that. There's no need for you to do long division or synthetic division. That's not a requirement here. Okay. Now there's a second part, B Roman 1. You are now given, this is a different polynomial altogether, so it has nothing to do with that. It's just essentially the same sort of topic. So they are saying this is defined, this polynomial is defined by f of x is equal to 2x cubed minus 7x squared plus 11x plus 4. They say we are supposed to find the quotient and the remainder when f of x is divided by 2x minus 1. So of course, there are many ways that you can do this. You can use, you can use long division, right? I'm just going to introduce or use synthetic division. Even if you haven't done it, please doesn't mean you should just do it. And remember, the idea is not to lose marks in the exams. Use the method that works for you, but also remember that time is a factor. I'm going to write the coefficient and make sure that the coefficients are in descending order. So if there's a term missing, perhaps we're going to put 0 in that place. So 2 is going to be the coefficient of x cubed, the other one is -7, the coefficient of x squared, you have a positive 11, you have a 4 there, okay? And then what we do is we're going to look at obviously this. So we are going to say, I'm going to say this -1, I'm going to divide it by that 2. So that's going to be -1/2. Okay, right. If this method is not familiar to you, please use any others. You can also have a look at my channel and you can see quite a number of questions on synthetic division. Right. Uh, if you now multiply -1/2 times 2, these at this instance, I'm just trying to show you how to find the answers, but as an AS level candidate, we do expect that you should know. And you do that, you're going to get -1 as an answer. So what I do is I'm not adding, I'll be subtracting, okay? I'm going to subtract -7 minus -1. So that means I'm saying, for example, -7 minus -1. So I'm going to get a -6 over here. So I'm going to be subtracting as I go. All right. Again, if you have a half times half times 6, right? That's 3. And the answer will be positive 3 because it's a negative times a negative. Okay. When you subtract 11 minus 3, you get an 8. Okay. Hopefully you're with me. A half times 8 is 4, but there's a negative. So negative a half times 8, that is -4. So this one over here is going to give me whatever the remainder is. Remember, again, I said you subtract, so you say 4 minus -4. Of course, if you do that, you get 8. So eventually, I'm not yet done. I'm just going to write down what this now indicates. This is 2x, 1 power less than that, 2x squared minus 6x plus 8. The remainder is the remainder. That is the remainder. There's nothing that I will be doing. I'll just carry it over. But because I have a division of 2 here, I must also divide all of this. I must divide essentially by 2. Okay? So I'm going to divide it by that 2 over there. So if I do that, this is obviously going to now give me a very nice answer, which is x squared, so this 2 goes into there, minus 3x plus 4, and then you have a remainder, and the remainder, I'm going to write the remainder as plus, because it's a positive, I'm going to put it 8 all over, that 2x minus 1, what you were dividing with originally. Okay, or you can say remainder is equal to 8. It's totally up to you. The reason I do that is because this question has a second part to it, all right, that you will have to use in order to solve that part. Right, again, whatever you do, as long as you get to that for 3 marks. Now, let's see what the second part is. Now, they say we are supposed to find the integral of f of x, the function that we had, all over 2x minus 1. So that function can actually now be written differently, okay? Because we have remember, you should also know how you are supposed to integrate certain functions here. I'm just going to rewrite what I have. The whole function is actually, right, I'm going to say, well, the whole function is actually x squared from before minus 3x, okay? This is the stuff that I'm writing. This is my little cloud kind of thing, yeah, plus 4, okay? So plus 4, let's just make our plus look nice. All right, so we're going to have plus 4, and then we have plus the remainder, which was 8, all over 2x minus 1 dx. Okay, we are going to be integrating with respect to x, the x-axis. Right, so this is definitely an indefinite integral because there are no limits. So there is going to be a scenario where you are going to put your constant of integration. Now, I just want to separate this because you can do that. So this is the integral of x squared minus 3x plus 4 dx, okay? And then I have what plus the integral of 8 all over 2x minus 1 dx. Now, this, I expect that you should definitely know how to integrate this, right? I just want to, we can actually start integrating here, or let me just rewrite it, x squared minus 3x plus 4 um, dx. And then I'm going to pull out this 8. You can do that. You can take out this constant, put it in front of the integral, and then you have a 1 all over 2x minus 1 type dx. Now, the way that this is done, and you should know your laws over here, so I'm just going to write this falls in a certain type that we integrate. And those are, see if I have space, those are, if you just have to look at a rule, those are the type where you are supposed to integrate a 1 all over ax plus b with respect to x. This is supposed to be, 1 divided by a, so that's 1 divided by a, and then you have, the same, the natural log of the function ax plus b. Of course, this should be absolute value, it should be positive, okay? And then obviously what you do is you say plus the constant of integration, right? So I can definitely also make those values, the absolute values there, unless, there is no way that this stuff here, ax plus b, should definitely be positive. That's what we write when we are saying something should be positive. So that's what I'm going to apply when I integrate that second part. This first part should quite relatively be straightforward when you are integrating. When you're integrating, you're not going to write or make the integral sign. So you're going to add 1 to the power. So that's going to be x cubed. And then you divide by that new power minus 3x, add 1 to the power. There's like a 1. And then you divide by the new power. And then remember, this is like 4x to the power of 0. So adding 1, you just say 4x over there. Plus, now since I'm running out of space, I'm just going to continue underneath here. So I have got my 8, it is here. Then I'm going to say 1 all over 2. So I'm going to multiply by 1 over 2. And then that's going to be the natural log. I'm going to put this in the absolute value brackets because this is supposed to be positive, all right, of 2x minus 1. Of course, then I'll slap the constant of integration. So all of this is just supposed to be on one line. So I'm going to rewrite it nicely for you to see what is my final integral going to be. So it's going to be x cubed over 3 minus 3x squared over 2 plus 4x, a half times 8, that is going to be 4. And then you have the natural log of the quantity 2x minus 1, which should be positive, plus the constant of integration. That is the solution to this question. Okay, right. So in this particular case, we are expecting you to be familiar with some of the laws of integration and you apply them. Okay, and where need be, from time to time, I will be writing the laws down or the rules or the formula that can help us, find or solve a question. And I might write it within the problem, right? So I'm using the space here where the margin is. You are not going to use it in the exam. You should strictly work where the lines are because this is where the examiners are indicating their marks and so on. Right, that brings me to question 3. Question 3, just want to minimize it a bit for myself here. The diagram shows the curve of y equals to x squared multiplied by the cosine of x, and x is an angle that is between 0 and a half pi radians. Okay, so I need to put the half pi radians over here because that is what they are saying. So this is a half pi radians, which is like 90 degrees, okay? So if you do have the paper, then also indicate that. And then the maximum point, as you can indicate, is at m, and something very interesting, at the maximum point, at this point, you should definitely know that the derivative of this is 0. The gradient there is 0. Okay, I'm just bringing that out because it's perhaps where this question is going to lead to. So, right. But first part, they say show by differentiation that the x coordinate of m satisfy that equation, which is given as tan x is equal to 2x. Right, so what we're going to do here is we are going to differentiate, uh, and then we'll see what that gives us. Because the x coordinate here, for us to definitely, find that x coordinate or whatever it is satisfying this equation, we have to, because it's at a turning point, we have to differentiate this. So it's going to be d by dx of the function x squared. I'm going to write the cosine in red, and the reason I'm doing that is because I want you to remember that in order for us to do this, we have to apply the product rule, okay? And the product rule is also something that is given, in the list of formula. So what does the product rule say? Well, it says there are many ways you can interpret it. Essentially, I'm going to keep the first term and I'm going to derive the cosine. And you should know that derivative of the cosine of x is minus sine of x. Okay, should not forget that. That is the derivative there. And then we are going to be adding, so we are going to keep the second one being cosine of x. So we're going to keep cos of x, and then we are going to be deriving the x squared term. And when you derive the x squared term, it's just going to be 2x. I'm just going to write 2x here. So essentially, I can actually clean this up. Please, we are applying the product rule over here. All right, and what does the product rule indicate? The product rule is indicating that whenever you are differentiating, say, d by dx of two functions that you multiply, suppose one function is u, the other function is v, what you do is you keep one function, then you find the derivative of the second function, okay, of v, and then you add and you keep the second function, which is v, and you multiply that by derivative of the first. Okay, there are many ways you can write it. Essentially, this is what I have done there. Keep the first, x squared, the derivative of cosine x is minus sine x, add, keep the second, which is cosine x, and then find the derivative of x squared, which is 2x. Of course, you can do it the other way around, meaning you can derive x squared, keep the second, because you are adding, and it will definitely give you the same output. So let me just write down what I have so far. So dy dx, therefore, dy dx is equal to, if I have to write it out, it's going to be minus x squared sine x, okay, that's this 2 here, and then I'm going to put that plus 2x in front, and obviously cos x. It simply looks slightly better, right? I'm going to let it equal to 0 because of the turning point, and that is what we are now looking for. Remember, when you are doing this, you're finding the x value. Whenever you derive something and the derivative is equal to 0, you find the x value, and that is what we are interested in. And the x value to give us, to satisfy this equation. So that is what we need to establish over here. Right, and as you can see, there's some tangent involved there as well. So that is also a guiding factor that somehow where we have sine and cosine, we need to change them so that we can have them in terms of tangent. And you should know at this instance, the tangent is nothing but sine over cos. So what I'll do, I'll divide here by cos x. I'll also divide here by cosine x. Of course, if I divide here by cosine x, it's obviously going to give me 0. So I'm going to have minus x over here, and this is the tangent of x, and then I've got plus 2x times 1, all right, and that is equal to 0. So you can see I'm very close to what I need to prove. Right, I'm also needing a little bit of paper, so I'm just going to insert a page here. So let me just find where my pages are. So maybe we say page, maybe I append a page and I'll just take, blank one. All right, so I can continue from there. So you have minus x, the tangent of x, plus 2x is equal to 0. Remember, what is it that we need to show? We need to show tan x is equal to 2 over x. Okay, right. So tan x has to be therefore isolated, and we can do that. So we can have minus x. There are many ways you can isolate this. Okay, is equal to negative 2x. I can actually drop the negatives because you have a negative and a negative on both sides of any equation. Essentially, it's just positive. So at the end of the day, I'm going to have that tan x is equal to 2x upon x. And I do believe this was there's a 2 there. There's a 2 there. So it's supposed to be 2x. Yeah, 2x over x. So let's just see where is it that I went out a little bit to see. Um, okay, let's just go back a little bit slightly. I can see my mistake. Can you see over here? There's a little square that I didn't bring down. So there you go. That square there. That square there. All right. Good. It's always nice to go back and make sure that you don't make mistakes in your working. That little square over here. And then you have a square over here. So eventually you're going to have the final answer is going to be the tangent of x is equal to the 2x cancel there over x. And this is what we were supposed to establish, and that is 100% correct. Okay, so I'm just going to scroll a little bit back because I have indicated the rule over here. That is why I kind of had to use that space there. All right. So that's part A of the question. So let's get to part B. Now they are saying we should verify by calculation that this equation, what is that equation? Well, the equation was um, tan x is equal to 2 over x, that there has a root, an answer that lies between 1 and 1.2. So there are those equations that exist that we are not able to just find their answers using other methods, and we use this method and iterations, as you'll see in a bit, to be able to find that. So one of the very important things that you need to do is you need to let this equal to 0. So when you let this equal to 0, that becomes tan x minus 2 over x is equal to 0. But we want this to be in a form of function, so I'm going to say f of x then is equal to tan x minus 2 over x. Now that I have that, and what you are going to do is for you to show that it has a root, you are going to substitute this answers into the function, and then we'll see whether they give you a change of 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 sign. So f of I'm going to put in the value. No, that should be a minus. Sorry, I'm going to put the value of 1. So I'm going to use a different. So in the insert 1, what is it that we get? So let's borrow our calculator and see. And make sure your calculator is in radian mode as mine is, because it's even clearly saying in radians. So we're going to have, the moment you have tangent and so on, you are using angles, and it's very important for you to know, is it in degrees or is it in radians that it's required. All right, divide that by 1. What do we get? Well, we get a negative value, so I'm just going to sort of take a screenshot of that. I'm just going to paste it here. Obviously, you will not take screenshot in the exams, but yeah. So I see a negative. Good. So let's then do the same and see what we get when we take f of, we're going to put 1.2 into the function and see what that gives us. All right, so when I insert 1.2, 1.2, 1.2. The moment I get a positive number, then it means there is going to be a root. Okay, so 1.2 over here, and I go back, and then obviously 1.2. Good. I get a positive value. So let me take a screen capture of that. So if it's positive, so there is a change in sign. Can you see that? The sign changed from a positive to a negative to a positive, and that change of sign indicate presence of a root. So you can just somehow write that in. So that's the change of sign indicates the presence of a root. Okay, so squeeze it in here. Change of sign, okay, indicates the presence of a root. Okay, good. So that was 2 marks, and that's going to bring me to the next, obviously, question. We're going to find a iterative formula. The iterative formula is x subscript of n plus 1 is equal to tangent, the inverse tangent of 2 all over x sub 1. So the idea is for us to find, because the root lies between the root that we're looking for, it lies between 1 and 1.2. So other people say, okay, I can actually say, since the root is there, and we have determined from part B that there is going to be a root because there is a change in sign when you substitute those into that function, right? Some people say, okay, let's just add where it passes, and then we find the mean. We divide the answer by 2. Okay, let's see what do we get when we do that. So we have 1 plus, okay, we want, let's go back. 1 plus 1.2, take a mean of that, so divided by 2, well, that gives you 1.1. All right, so it's like more or less we think the root will be at 1.1. You can even, divide it further by 2, but let's say we work with that. And that is going to be our first sort of, starting point. So we're going to say x of 1, where we are going to put 1.1. So say this is 1.1. Then, if I do go, I'm not going to put 1.1 and then get an answer. So that means I'm not going to say, remember it should be in radians. I'm not going to say, oops, that times. I'm not going to say, here. I'm not going to say it's 2 over, then I have 1.1, right? And then I see, okay, what is it that I'm getting as an answer? All right, I'm going to capture that for a minute. And then I'm just going to paste it somewhere here. Okay, so that's what I'm getting. And then I must go back to my calculator and then I say, okay, what will it be when I now go to, the next one? So, for example, substitute now that answer in there and see what the next one will be, right? So basically, say you're starting all over, you say, okay, wait a minute. I'm going to say the inverse tangent of is it 2 over, and then you go ahead and you put all this 0.90548, 49, what is it, 3.5, I might have left something out, and then you write, oh, I'm getting some 1 point something, and then you continue, right? I'm just going to capture that. Then you say, okay, this is what I'm going to get, in the second instance. Then you're going to write and say, oh, wait a minute, this is what I'm now getting. I'm saying, okay, x of 2 is equal to this value. And by the way, they are saying the final answer will give correct to 2 decimal places, but these iterations that you have here, all this must be to 4 decimal places. So for like your first one, it's going to be like to 4 decimal places, it's going to be 1, 2, 3, 4. So it's going to be 905, what is that, 5. And then your second one, you're going to say 1.14566, let's say 66, right? And then once you now see what you're now doing with this is you'll be looking at your 2 decimal places and see what it converges to. Like if it converges to a certain number, that is what we're looking for. And that is where the root is going to lie, or that is going to be your root there. Okay, so I'm not going to take again 1.14 and manually put that in the calculator. So there is a way that we can do that. All right, so I'm just going to again just append the page because I just realized I'm going to need that. Okay, right. So the way we are going to do that is we're going to take our calculator. So I'm just going to clear all of this. I'm going to start with my first point, which is 1.1. So I'm going to press 1.1 and I press equal to. Now it's stored on my calculator as an answer. Right, so I'm going to take the function, the inverse tangent of 2 over. Now I'm going to press answer here, okay? And I'm going to close the bracket. When I hit equal to, right, you see that you are getting that, what is it? Now 1.1 was our first answer, sorry, goodness gracious, all right? 1.1 was our first answer. I just want to make sure of something here. I do realize that I might have made a little mistake over here. Okay, it's good that I'm seeing that. So let me just remove this. Can you see that I didn't put 1.1 here? Okay, so could even be a mistake in the second part and so on and so on. All right, so don't worry, bear with me. I'm going to explain, in detail because I made a mistake with that first one. It's going to affect my mistake in the second one and so on. So it kind of made my point a little bit mute. All right, so let's say we do it manually. So the inverse tangent of 2 over, okay, what we have, we're at 1.1, okay? That would be my second answer. Okay, so that had been, what was it? Okay, that's what we have. Right, looks familiar. Okay, it's in the correct one now, okay, because we're using the wrong one anyway. And then now you go back and say, okay, I'm going to go back and I'm going to put now this whole decimal there, 0679, I'm reading off from here, 53116, 53116. And you say equal to, you get, okay, this is what I'm getting, and then you're going to write that down, and then you do exactly the same. Now, that's not what we're going to do. So what I'm going to do, I can do that, but you will quickly see. Right, so again, you will be writing this to 4 decimal places because it's too much, to write. So 1, 2, 3, 4. So you'll be saying, well, first one is obviously 1.1. This was, this is going to be the second. That was the first. So let's just going to write it slightly below. Just bring that one down a bit. Okay, that was the first one. This is the second one. And this is the third one. Okay. Now, a lot of people asking, how many of these iterations do you need to do in order for you to find an answer? So this one here is 1.0679. So 1, 2, 3, 4, 9, that 5, 4 decimal places. Then you have 1.08033. Okay, can you see 2 decimal places is not far from each other? Okay, eventually it gets to something. So what we do is we're going to grab the calculator and I'm going to say, good, starting off from the first 1.1, press equal to, store that, the calculator is not storing it. Now find the function, okay, it's 2. I'm going to put answer here, okay, you have it. And I'm going to press equal to. Can you see that answer is the second one, okay? Then all you do is continue press equal to. Can you see this answer is the third one? Can you see that? Right, so we're going to have the fourth one, but just keep on pressing answer. So equal to, I mean. Right, so let me capture that, okay? Capture that, and I'm going to paste that over here. So this is the fourth iteration. Does that make sense to you now? Okay, so this is the fourth one. Okay, there we go. So what is going to be the fifth one? Already I can see something happening, no? Yeah. Is that it? It's the wrong one that it captured. Okay, good. Captured the wrong screen. Captured the wrong screen. We already had that one. Okay. This is the one I'm looking for. Good. That's the fourth one. What's going to be the fifth one? The fifth one, obviously, this is going to be much faster when you do it in the examination. I just want to show you. Press equal to. Okay. And you copy it, capture it, or you're going to be writing it down, obviously, right? And let me do one more because I can already see to two decimal places is 1.08. Can you see that? 1.08. I don't even need to continue. Okay, I'm just going to do it now. Okay, so that is, I'm going to go up to there. So let's go to a calculator, hit equal to, yeah, it's 1.08. Capture the screen. I'm going to paste it. Right. Right. If you now look at what you have to two decimal places, of course, remember you are going to be writing them here to four decimal places as indicated. Maybe I should do that as well. All right, to have a little bit of consistency. So this is like 1.0755. That's 4, and then that's a 3. And this is nothing but 1.07739, and this is nothing but 1.07667. Now when you are comparing, you will see that not much is going to change. This is all converging to a number, and that number to two decimal places. Can you see that? We have made quite enough iterations here to then conclude that the root x will equal to 1.08 to 2 dp. That is enough iterations for us to do that conclusion. And that essentially is what we're looking for. Okay. Right. Of course, I took a bit of time explaining that, but hopefully you do understand the concept of iterations for you to find that root where it would be. And I chose a number that is halfway between 1 and 1.2. Okay, you can actually, if you want further, you can divide that number further by 2, and so you can just get, it brings you closer to what that root will be, and it's eventually 1.08. This should work normally in an examination center. Sometimes you find yourself having to do 3 or 4 or more iterations, but I can't see a scenario where you have in the examination a question that will, require you to do 50 iterations. All right, so don't overthink the problem as well, and read it very carefully, and obviously follow the instructions. All right, so that's it for that question. That will bring me to question 4. The diagram shows part of a curve whose equation is equal to y equals to 2 cos square x plus 5 cos x minus 3, where x is measured in radians, and then obviously the curve is crossing the x-axis at the point P, as you can see, and the shaded region is bounded by the curve and the axis, the x-axis and the y-axis, which is the line y equals to 0 and the line x equals to 0. Okay? Then I see what I said in the beginning, exact value. You are now going to find the exact answer. X coordinate of P. They are saying coordinate, right? It's 1. But you look at the equation, this is in a quadratic, it's like a hidden quadratic, because essentially what this means is when you have quadratic equations, you're going to have 2 solutions. Does it make sense to you? And you have to choose the one that makes sense. Obviously, if I do get a negative answer is not going to be in that first quadrant, as you can see clearly by my curve. Good. So it's totally up to you. Some people, they will replace the cosine of x with a k or any other letter for that matter. Whatever you do, get to factorizing this. Okay. So if I factorize, I'll get 2 cosine of x minus 1 as one bracket, and the other one is cosine of x plus 3 in one bracket. Of course, you can also use your quadratic equation formula. And if you do that, this is your value of A, that's your value of B, that's the value of C. All right? So I'm going to come to the quadratic equation formula in a bit. Let's just solve this question over here. You're going to let every bracket equals to 0. So this is 2 cosine of x minus 1 is equal to 0, or cos x plus 3 is equal to 0. Then obviously this is going to be cos x is equal to 1/2, or cos x is going to equal to negative 3. Now, you do know that the cosine graph doesn't go all the way up to there. So this is something that you will be rejecting. Please remember the cosine graph starts at 1, goes down, and come back. So it goes between 1 and negative 1. So there's no way you're going to have that negative 3, not for this function y equals to cos x. So that's why I'm rejecting that. So this is what we're looking for. And also from special triangles, okay, you can obviously use your calculator. This is exam. Special triangles, and this is obviously 60 degrees. 60 degrees is pi over 3, and that is pi over 6 over there. The cosine of 1 is going to be cosine 1 over 2. X is equal to pi over 3. This is the acceptable answer. Okay. Now, of course, if you don't know all these special triangles and stuff like that, you tend to forget them. Or pressure cooking scenario, we are in the examination. That should be in radians. Inverse cos 1/2. Okay. Make your life easy. There's the answer. Good. We are where we are. Okay. Perhaps I must just exactly don't go and change that to a decimal. This is unnecessary for you to change from third to decimal. Then you write that. The question clearly says exact value. So that's the exact value. That's what it is. It's pi over 3. Pi over 3. Pi over 3 is 60 degrees. Okay? And it should be in radians. Because you are told that these things are measured in radians. So please read your step very, very careful so you don't make unnecessary mistakes as you go along. Now, I did promise you that I'll show you how to use the quadratic equation formula to solve that. So perhaps I should do that, and so that I can, give you also another sort of perspective. Okay, so for me, let me just see if I can take a snapshot. Hopefully, I'm not getting any problems. If I take a snapshot of that, okay, I'm just gonna paste it over here. Right. So we said we're gonna take a using the quadratic equation formula. We know what A is. We know what B is. So it's cos of x is equal to, well, minus b, in this case is 5, plus minus the square root of 5 squared. I don't have to put it in bracket because 5 is positive. Minus 4, a is 2, and c is negative 3. All of this stuff, okay, just complete that square root over there. All of this stuff you're going to put over 2a. Well, the value of a is nothing but 2. Right, so I did substitute my values a and b into the equation, and I'll be getting my answers. So this is going to give you cos of x is equal to, so grab your calculator, have your one value, so negative 5. Let's take positive, take the square root of 5 squared minus 4 times 2 times negative 3. Hopefully it will give me. And then you put that over 4. 2 times 3 is 4. Okay, there we go. Can you see I have a half? Good. 1/2. Or cos of x is equal to, let's go back. I'm going to change this plus to a minus. So I'm going to go all the way back. Right? Square root means there are two possibilities. I should give you negative 3. Can you see that? Negative 3, which is the answer that we reject, because I did explain that. And you work from cos of x is equal to a half, which brings you to this same scenario. And then since the angle is in radians, x is equal to a third of pi. You can write it like this, or you can put a pi over the 3. Same thing. Good. Same thing. Right, let's go to part B of the question. They say now find the exact gradient of the curve at P. I think I should bring down that diagram. Let's just see if I can take a snapshot of the diagram so I don't have to go back and forth like this. Right, so if I bring the diagram to part B, I'm just going to paste it somewhere over here, make it a little bit smaller for it to fit. Right, what do we know? We know that the x coordinate here, the value of x here, we know it is pi over 3 because it's in radians. They want us to find the gradient of the curve at P. Now, that gradient is very interesting. You can see that by the look of the diagram, that gradient will be a negative number. Okay, but whatever that number will be, it's going to have some roots and things like that because we are supposed to give the exact answer. Right, so bear with me. What do we need to know? Well, in order for us to know what the gradient is going to be, we have to differentiate this function. What is this function originally? Okay, originally the function was, okay, it's not indicated, that there's the function. It's 2 cos square x plus 5 cos x minus 3. Okay, so I'm going to write that function down. That's the function. Okay, right. So the function is y equals to, it's quite long, 2 cos square x, what is it, plus 5 cos x minus 3. So what we need to do is we need to differentiate that 2 cos square x plus 5 cos x minus 3. And there are a little bit of certain rules that you need to know. Of course, I'm going to be making use of the chain rule a lot over here. Okay, I'm just going to write it a bit separately in terms of differentiation. That is d by dx of, let's say we take 2 cos square x, right, plus d by dx of, let's say, 5 cos x. I can go ahead and change the other one, minus d by dx of 3. Okay, hopefully you understand that. So I'm going to do this part over here. Now, this part over here, I'm going to use the chain rule. So I'm going to do it in 3 parts or 2 parts. This one is easy to differentiate. The derivative of that is 0. So I'm going to look at those 2. So I'm going to do, let's say this is part 1. Okay? And let's say that's part 2. Part 3, we know the derivative of that is going to be 0. So here, so if I do d by dx of 2 cos square x, because this means cos x times cos x, which can be written as d by dx of 2, that cos, maybe I must take that bracket away so I don't get confused. So I can put a 2 here, and then I have cosine of x all squared. That's exactly what it means, exactly the same as that. Right, so using the chain rule, how do one differentiate this? Hopefully you still remember. So let me say I've got y equals to 2 cos x all squared. That's one part. And then I say u is equal to cos x, the stuff inside. Okay, so the stuff inside is going to equal to u. Then I can rewrite this one as y equals to 2u squared. Now I will be differentiating both of them. Right, so I'm going to do this one here. This one, maybe I'd write it in blue. This is dy du. It's going to be 4u if I differentiate this one. Then this one, I can write it in a different color, maybe green. This is du dx. Now, the derivative of cosine is nothing but minus sine x. There we go. Right, I definitely need to put pages in here because we'll need more space. Okay. You have blank pages in the examination if there is a mistake or something that you do. Right, so what does it give me? Now I know that dy dx is going to be dy on top times dx is on top, and what you're going to have du here and du there. Okay, it's like those u's cancel. Right, what is the value? Remember, u was equal to cosine of x, if I'm not mistaken. So when you do dy dx, dy du, which is 4u times du dx is from here, minus sine x, that is minus sine x. This is multiplication. Right, so at the end of the day, dy dx is equal to negative times that is negative 4. U is cos of x sine of x. Okay, I hope I have done justice to that. Just remove that stuff. Okay, then, so this is my first part. I'm just going to combine them later. Let's look at the second part. Second part is this one. Okay, so let's just take a snapshot. It's this one. I just write the whole thing, bring down the whole thing. Okay, the whole thing. Let's bring down the whole thing. Okay, the second part of that. The second part, I was saying, okay, this is d by dx of, well, I don't need much here. I can just go ahead straight and say dy dx. The derivative of cosine is nothing but sine minus sine. So this is going to be equal to dy dx is equal to minus 5 sine x. That's what that is. Okay, plus 0. The derivative of that is going to give you 0. So end of the day, it's basically the same as minus 5 sine x. Does that make sense? Right, so I'll combine the two now in order for me to find what is the derivative. I'm going to bind the 2 again. So at the end of the day, dy dx is equal to, what was that first one? The first one was minus 4 cos x sine x, okay, minus 4 cos x sine x minus 5 sine x. You got it? Right. That is what I want. Now they are saying, the question was originally saying from the diagram, find the exact gradient at P, and at P you have the x value, which is pi over 3. So I'm going to substitute that into the derivative function and see what I get. Okay. Again, I'm going to include another page over here. So dy dx, when x is equal to pi over 3, that's minus 4 cos of that sine of that minus 5 sine of that. So I'm going to substitute obviously that over here, over here, over here. Good. So this is going to be pi over 3, pi over 3, pi over 3. So you do have a calculator where you can play around with this. Okay. From special triangle, maybe I should do my triangles over here. Let's say I know that that is 2, the hypotenuse. I know this is half pi radians or 90 degrees. This is 1, and this is 60 degrees, which is pi over 3, and that is pi over 6. Okay? And this is going to, using Pythagoras, this is going to be the square root of 3. This is special angle, triangle. Right, so we're going to use that to solve this. For the cosine of pi over 3 is 1/2 from here, cosine, adjacent of hypotenuse, times the sine of that. The sine of that is root 3 over 2. You can use a calculator to verify. And the sine of that, again, as we said, is root 3 over 2. So this is what we are dealing with. So in terms multiplying numerators of numerators, I'm going to have 4 root 3 over 4, the 4's cancel, minus 5 root 3 over 2. Are you with me so far? But that 4 is negative, so let me not forget my negative sign again. Right, we're nearly where we need to be. Of course, those 4 cancel, leaving with root 3 minus negative root 3, right? Minus 5 root 3 over 2. Essentially, this is over 1. Then making the common denominator, that is multiplied out 1 by 2, that's negative 2 root 3 minus 5 root 3, everything over 2. And then the root 3 is there, you can think of them as operators, so I'm just going to subtract minus 2 minus 5, you know, these are negative 2, negative 5. So at the end of the day, I have negative 7 root 3 over 2. That is the solution, okay, to all of that. And you can see it's gradient, it's negative. So even the way the diagram looks like, you can see that supposedly if you were to say draw a gradient line, it's going to be kind of tough here. But let's say that gradient like this. That line is going to be negative. That gradient is negative. And that is what we indicated that gradient to be. That is the gradient that is negative 7 root 3 over 2. That's the gradient with that line. Okay, right. So a lot to unpack there. Again, take your time. Make sure that you understand the stuff that we have done. Essentially, this is supposed to be like a revision, something for you. All right. So please don't don't give yourself stress in the examination. You know, when you don't know this special triangle stuff, or you sure that I might make a mistake, use your calculator. Okay. You press on your calculator. It should be in the radian mode. If you say cos of pi over 3, okay, of pi over 3, that's going to give you that half. Okay, you can close it or close the bracket if you want to. You're going to get that half, and that is where I'm working from. And you can do the same when you want to find the sine of pi over 3. It's going to give you that answer. Okay, so sine of pi upon 3. Okay, so that's going to give you root 3 over 2, and so on. And then you clean it up, because here you can't be just directly punching things in the calculator. You have got the square root somehow there, and the answer should be an exact value. And I indicated right from the onset, be on the lookout for exact answers. They might imply that your answer should be left in terms of a radical or a pi or e, whatever the question demands for these irrational values. Okay, right, let's go to part C of the question. Now, part C of the question says, by expressing 2 cos squared in terms of double angle cos 2x, find the exact, you see in this question, we deliberately decided to keep on finding exact answers, drill it into us for us to understand something. Okay, let me just write down what was the function. It was y equals to 2 cos squared plus 5, what is it, cos x minus 3. This is the one, this part. They are saying we should write that part in terms of a double angle. Now, if you don't know, then obviously you can go all the way down, and you can go all the way down to your formula, and you can go and check which one is it that you need to be able to pick. Okay. All right, so let me just go and sort of grab them, so you can also see how you should use that. Those things are not just there for show. All right, so we go to trigonometry and we are dealing with our double angle. This is the one for cosine. Okay, see where is our snapshot, and the double angles for cosine is over here. Okay, I am inclined to come and collect the other one, but I'm gonna, let's cancel. Let's take the double angle. Let's take all of them. For sine, cosine, and tangent. Okay, let's go back to our problem. And I'm going to paste them somewhere over here. Now, these things are given to you as cos square A, but we have cos square X. So please do not write A there. This is just for you to guide you. Does that make sense? All right. If you look at, they are saying we should write 2 cos. So I must highlight the 2 as well here. All of this we should write in terms of the double angle. Now, which one are you going to pick? There is either cos square A minus sine square A. There's 2 cos square A minus A1 and 1 minus 2 sine square A. Obviously, we are not going to change anything to sine. Okay, does that make sense to us? So, if you look at double angle, and you would know that double angle of cos, and I'm going to take this one that is identical. That is going to be, let's see, 2 cos square A, because it includes this cos square A. Can you see that's what I'm looking for? So I'm going to pick this one here. So that's 2 cos square x minus 1. This is what they are identical to. So where I have this, I can replace it with cos 2x. However, So when I now write it, because when they are saying find the area of the shaded region, this implies integration. Does that make sense? Okay, so if I look at here, how do I isolate the 2 cos square x? I need to get rid of that negative 1. So at the end of the day, the 2 cos square x is identical to the double angle of 2 of cos plus 1. So where I have this, I'm going to replace it with this. That's what I do. Okay? So when you see me integrating that curve, I'm going to integrate that curve from 0 to pi over 3, and I'm going to write my curve not like that, okay, but in the place of the 2 cos square x, I'm going to write cos of 2x plus 1, okay, that's the place of the yellow part, but I still have to continue, so just write that in a different color, but it's still part of the same thing, plus 5 cos x minus 3, and we're obviously going to integrate that with respect to x. Please don't forget that. Think of it as a bracket. You start here, opening the integral sign, you have to close it with something, okay? Right, now, before I continue, we can see that we can still clean up a little bit there. There's that 5 and negative 3. So this is definitely going to be the same thing as integrating from 0 to pi over 3, and this is cos 2x, and then you have 1 minus 3. Okay, so I'm going to put plus 5 cos x in front, and 1 minus 3 is nothing but negative 2. Okay, dx. Now, where am I going with this? I'm going to bring in my rule. Remember, I like my rule. You should definitely know how to integrate 5 cos x, and I have shown that. How do you integrate cos 2x? This is very easy if you know the rule, right? So, rule time. How do we integrate cos of ax, for example, with respect to that? The way we integrate that is with a 1 over a, okay, very important. Then the derivative of cosine, okay, this is supposed to be something that you should know. The derivative of cosine is not the derivative, sorry, my goodness gracious, the integral. Integrating the integral of cosine is sine. So this is going to be sine of ax, obviously plus the constant of integration. Does that make sense? So in this particular case, knowing this rule, which I am going to apply over here for this one, okay, if I do that, it's going to be 1 over 2, which is where that 2 is, so just going to rewrite it in black, integration time. So we are going to say that is 1 over 2, 1/2. The integrating cosine is nothing but sine of that double angle of 2x. That makes sense to you? Okay. And I'm going to continue plus 5. Integrating cosine is nothing but sine x. And then obviously integrating minus 2, that's minus 2x adding 1, right? And we're going to do this from 0 to pi over 3. Okay. Right. Okay, we're nearly there with this question, so let's just go ahead and also include another page because I need space to work. Right, so I'm going to put my upper limit of integration. So it's going to be 1/2, okay? Then this is going to be sine of 2 times the angle being pi over 3, which you can find on a calculator. Don't give yourself stress. It's not worth it. Plus 5 sine of pi over 3. You can get it on a calculator. You can look at the special triangle if you want to, but we're going to use a triangle for now. Minus 2 times pi over 3. Can you see that? That is obviously, maybe I'm going to say we are going to subtract this minus. I'm running out of space, so I'm just going to write the same stuff, and I must include. You must show the zero. You're going to just assume that everything is going to be a zero, right? So what's coming here is going to be written underneath here, which is a half sine of 2 times 0 plus 5 sine of 0 minus 2, 0. Okay, we need to find that answer. So let's get our calculator and see what we get. Oh, okay. Since the answer is supposed to be exact, so be very careful. So I'm just going to put in sine. Again, it's in radians, sine of 2 pi. 2 pi over 3. Where am I getting 2 pi? It's here, right? 2 times pi over 3 is 2 pi over 3. I'm interested to know what that answer is. Okay, root 3 over 2, which you should know anyway. So just using a different color, I have a half. I'm going to multiply by root 3 over 2. That is what this is, plus 5. The sine of pi over 3 is also root 3 over 2. Okay, if you want to see that, I should show you. Root 3 over 2. Okay, for special angles, you should know this. Okay, sine is positive in the first and the second quadrant. Minus, okay, this is just 2 pi over 3. We good? Well, I'm going to have minus 0 here because all of this is going to give you 0. Sine of 0 is 0. So this whole stuff, the second part, will be 0. You need to indicate that. Okay. Now let's clean up the fraction because we're supposed to leave the answer as an exact answer. So first of all, this is a root 3 over 4 plus 5 times root 3 over 2 minus 2 pi over 3. Good. That pi, I'm going to leave it there as an attachment. So I'm going to take these two fractions. When I take these two fractions, I'm going to make the denominators the same by multiplying here by 2. So it can be 4. And I'm also going to multiply here by 2. So I have got root 3 over 4 plus 2 times 5, that is 10. Okay. Is it? That's going to be 10. Is it 10 or 11? Okay, I will see exactly. Okay, it's 10 here. Root 3. I see where my 11 is going to come because there's a 1 here, right? Over 4. Let's leave our attachment there. Let's simplify it now. We are close to being done with that. So at the end of the day, these two, I add the numerators together. That is going to be 11 root 3 over 4 minus 2 pi over 3. This is going to be the exact value. All right, this is area. Okay, let's just go back. They say find the area of the shaded part. So that is the area, and then perhaps say units squared. Here you go. That is the final answer. I know it seems like a lot, but you know, at the end of the day, once you get the hang of it, you get the hang of it. Okay. Right, let's go to question 5. You are asked to solve the equation. It's a natural log equations in terms of natural log. So first part is solve that. So we expect values of x. You should also be very careful what your values of x are. You know, looking at the natural log of anything here, right, should be positive. That's why I put the absolute value there. So x minus 2 cannot be 0, should be greater than 0. X minus 2 should be greater than 0, so x should be greater than 2. So obviously also x should be greater than 0 from here. So these are the conditions that you need to be on the lookout for. Now, how do you do this? Well, this is quite straightforward. So it's ln x squared minus ln x minus 2 is equal to ln 9. Okay, you have subtraction here, you are going to be dividing, so you have x squared upon x minus 2, put this in bracket, is equal to the natural log of 9. You can go ahead and drop those natural logs, so you have x squared and then over this, and you can put that 9 over 1. You can actually cross multiply in order for you to find the quadratic. and the quadratic should factorize. So it's going to be x squared is equal to 9x minus 2 when you do that cross multiplication, which eventually gives you x squared minus 9x plus 18. I hope you are with me when I do this and I move them to the other side. So at the end of the day, this should factorize. That's a positive, so I have two minuses as indicated by that sign over there. And it's 6 and 3, so I'm going to give you the 18 and 9. And then obviously you should be able to see your answers. X minus 6 is equal to 0, therefore x is equal to 6. Or x minus 3 is equal to 0, therefore x is equal to 3. What was our condition? We said x should be greater than 2. Yeah, 6 and 3 are pretty greater than that and greater than 0. So those are the solutions that will satisfy this equation, right? So there you go. At the end of the day, those are the solutions. Let's go to part B. So I'm just going to be writing the equation that I had in part A. I'm going to write it over here on top. The equation was 2 ln x minus, then you have ln x, so you have in bracket it was x minus 2, I believe, that is equal to ln natural log of 9. Okay, so again, it's a scenario like what I had before when you look at similar things, where you had your E5, your X, you should definitely see that relationship there. The relationship is that X, the natural log, no, not natural log, my goodness. You should see that 5u is equal to X from this deduction. You can see that, okay? But what was our values of x? It was 6 and 3. Good. So we are going to write two equations. We're going to say, okay, not 5u, my goodness gracious, 5 raised to the u. Okay, that's the max. So therefore, 5 raised to the power of u is equal to, from before, what was our solution? 6 or 3. So 6 here, or 5 raised to the u is equal to 3. Right, since it's a natural log, I'm going to give you the natural log, and I want the answer in fraction form, so you're going to take the natural log of both sides, okay? And then obviously the idea is to make u the subject of the formula, so you're going to bring it to that u in front using the power law. And then u would be as a fraction natural log of 6 divided by the natural log of 5. And we're going to do the same on this side. We're going to say the natural log of 5 to the u is equal to the natural log of 3. In this particular question, we might just condone logs. So you give me your answer in log form. So natural log of 3 divided by the natural log of 5. Essentially, that's what we're looking for, and those are the solutions. So the answer is a fraction, can you see? It's a fraction. Natural log of 3 upon natural log of 5, or natural log of 6 upon natural log of 5. Good. You could use log 6 over log 5. That's basically what I'm saying there. Right. Let's go to the next part, part B. The variables x and y. They satisfy the equation, that very big, horrible equation, y equals to b, e raised to the k in bracket x plus 2 quantity. B and k are constants, which we are going to be asked to find, corrected two significant figures. The graph of the natural log of y against x is a straight line passing through the points 4, 3.5. And the other point, obviously, I said passing to the point, but you can see the other point in the diagram. And the other point is very necessary for you to know that this particular point is the point 0, 1.65, okay? Points are always given by x coordinate, y coordinate. X coordinate, y coordinate. Very important. Okay, good. Good. We need to find the values of x and y. So let's just write that um, equation. Let me just go take a snapshot of it and I bring it over here. Come to Papa. Okay, we're gonna put it over here. Oops, okay, here we go. Now we are going to take the natural log of both sides. Okay, so I'm going to say natural log of y is equal to the natural log of, and then I have in brackets b e raised to the k x plus 2. Okay, good. Then there is a multiplication here. So remember, it's like this and this one, they multiply. You know, when you have a scenario like that, again, just remember the laws. You have natural log of, let's say, AB, it's the natural log of A plus the natural log of B, right? That's what we're going to do. So I'm going to separate this side. So natural log of Y is equal to the natural log of B, with me, plus the natural log of E, and I'm going to multiply out this bracket, or not necessarily, let's leave it like K x plus 2. We are getting somehow, somewhere. Okay, right. So from here, this can actually come down. And another thing that maybe let's just rewrite it first. So I have the natural log b, which is a constant, plus k and x plus 2 natural log of e. Another thing that worth knowing is the natural log of anything of e is nothing but log base e of e. So this ln stuff is log base e. That's what it is. And knowing your rules, if you have something like this, then this answer is equal to 1. Okay? This answer is equal to 1. So therefore, this answer will equal to 1. So there's no need for me to write ln e. Ln e is equal to 1. So therefore, ln e is equal to 1. That makes sense? Good. Now, from your log laws, let's continue with that. Let me just rewrite it again. So I have natural log of y is equal to, I'm going to write that k x plus 2 in front here, plus the natural log of b. For now, didn't have to do that, okay? But there is this obvious reason. Didn't have to do that. Good. If this natural log of b, this is a constant, but there is also something here with a constant involved. So I'm going to say, let's multiply out k times x is kx, and k times 2, well, that is 2k plus the natural log of b. My reasoning is here. All of this is represented by a constant. Okay, that's a constant. All of this, it's a constant. Okay, what constant is that? Well, the y-intercept. We're going to come there, right? The y-intercept. So I'm going to, which is the y-intercept. Very important. Why that is important for us to consider, right? Because if you look at the diagram, and I'm going to bring that diagram here because that concept is very important. Let's take a snapshot of my whole diagram, even with what I wrote on this side. So I'm going to bring that over here, come to Papa, and I'm going to put it here. Good. Now, to make it a little bit smaller. So what is the y-intercept over here? Now, the y-intercept is at 1.65. So what does that imply? That implies that 2k plus the natural log of b is going to equal to 1.65 because it's the y-intercept. Okay, I have a slight problem there. I need to have a k value before I can find what the natural log of b is. From the equation written in this form, if you were to write this equation in the form y equals mx plus c, where this whole stuff is c. The m here is k, the gradient is k. Therefore, the gradient is k. Right, so I can find the gradient. And how do we calculate gradient? Gradient is calculated by taking two y values, 3.45 in this case, 3.45 minus 1.65. That's why I write xy there. So you do the correct subtraction. Okay, started with that point, so I'm just going to start with this 4 minus 0. If you work this out, it should give us already the value of k. So let's work it out. It's 3.45 minus 1.65. We're going to put that all over 4. Okay, that gives you 9 over 20. 9 over 20 or 0.45. I'm going to go with 9 over 20. Good. That is 9 over 20. Good. Which is k. So I have my k. K equals 9 over 20, which means I can substitute it there. Right? Do. So we go. We say 2 times 9 over 20 plus the natural log of b is equal to 1.65. Right, 2 times that is 9 over 10. Okay, this is 9 over 10 plus the natural log of b is equal to 1.65. Now, 9 over 10 is nothing but 0.9. Okay, so to isolate the natural log, b, say natural log of b is equal to 1.65 minus 9 over 10. Okay, right, let's see. 1.65 minus 9 over 10. What does it give you? It gives you 3 quarters. Okay, which is like, let me put it 0.75. Good, that's 0.75. Now, let's find our p value. I don't have space. I'll just include, I'm not going to be stingy with the papers. So I'm just going to insert them. Okay, it appears like my things have disappeared. Oh no, I've actually inserted the page at the wrong place. Okay, so let's go back. I need to insert it over here. Page, insert the page. Good, makes a little bit sense. Right, so what do we have? We have the natural log b is equal to 0.75. Remember what I said in a minute ago? I said that ln is nothing but log base e. That's ln. Okay? Right, so we're going to rewrite this from this form to exponential form, so that kicks that one up. So b equals to e raised to the 0.75. Okay? So we're going to have our value 0.75, so we can see what we get. Okay? I'm going to take a snapshot of it. And then I'm going to write it over here. Right, so this is the value of b. Now, they are saying that we are supposed to give our answer to two significant figures, and because they are saying that, I'm going to give my answer as decimal, especially for k. Remember, k was 9 over 220, which can actually be written as 0.45. So this is nothing but 0.45. Right, so let's go and make our conclusion. We say, therefore, k is equal to 0.45 and b is equal to 2.1. They are saying to one decimal place, or they are saying to two significant figures? Two significant figures. Two significant figures is 2.1. Okay, that's what it is. And that's all she wrote. Final answer, there you go. So be on the lookout for questions where you are specifically told what is it that you're supposed to do. Right, let's come to question 6. We are supposed to solve an equation. We have the equation, there's some compound angles issues here involved. So again, let me grab my, go back to my formula sheet for me to go and grab my, so you don't make mistakes when it comes to the compound angles, like sine of a plus b, sine a cos b, so on and so on. So where are we? We are here. I'm going to grab that. So we'll take a snapshot of it. So this is what I'm talking about. So I'm going to take essentially from this one because my question involves that. Maybe I take all of this too. Okay. We'll see. Because I think I should take all of this. Maybe I take all of this up to here. Maybe. All right. Maybe. Okay. So let's go back to our question. Now the video is long. Remember, you can pause it. You can watch it in real time at home, and so on. The idea is that you can follow and also learn and see where you have made your mistakes. All right. So I'm just going to paste all of that stuff over here. Good. They say solve the equation. So now I'll do that. The equation. So when you have this compound angle over here, so first things first, you know, you have got the sign here. So just highlighting that, you have the sign of that, which is the stuff that we are going to look at, right? And that's a plus, so you can consistently use the plus as indicated between the rule over there. So I'm going to write this as 2, but in bracket, sine theta plus 60. Please, this doesn't mean sine theta plus sine 60. That's not what it is. This is a serious mistake. It's sine of theta. Sine theta times the cosine of 60 degrees. Okay? Plus cosine of theta times the sine of 60 degrees. That's what that means. All right? That's what that part means, that first part. All the way from there to there, I've written it down. So I'm going to go and write plus. I'm writing out of space and then say plus 3 cos theta equals to 5 sine theta. Theta is an acute angle between 0 and 90 degrees. Calculator must be in degrees mode. Okay, what do we know from our special triangle, which you can use? Or you can use your calculator. Doesn't matter. If this is 60 degrees, this is 1, that is 2, that is root 3. This is 30 degrees, that is obviously 90 degrees. Good. So, where I have, say I'm starting all the way here, the 2 is outside, I have cosine of 60. Cosine of 60 is 1/2. You can use your calculator. That's cosine of 60. Then I have sine theta plus sine of 60 is root 3 over 2. So that's root 3 over 2. That is sine of 60 cos theta. Okay. And then I have 3 plus 3, cos theta. Now, this is important. This is just going to be theta. And this is equal to 5 sine theta. So, let's see where we are at. Okay. If you were to distribute the 2, obviously it's going to cancel. So, you're just going to be left with sine theta over here. That 2 and this one is going to leave you with root 3 cos theta plus 3 cos theta equals to 5 sine theta. Right, all of this, we are supposed to find theta to one decimal place. Does it make sense? Good. So we need to only work with one ratio. Okay, you cannot have sine and cosine, but we're going to get to that. Let's look at the coefficient of cosine, which is root 3 and that 3. Are we together so far? So I'm going to write them in brackets. I'm going to say root 3 plus 3. Okay, cos theta is equal to 5 sine theta minus the cousin, which is on the side. Does that make sense? This is 4 sine theta is equal to all of this stuff, root 3 plus 3 cos theta. Very important that you keep that in bracket. Now, one of the best ways you can deal with this is if you were to change this to tangent. That means dividing throughout by cosine. So let's just, again, the page story, insert a page there. Again, I inserted the page at the wrong place, so let's just go back there. Okay, that's what I need to highlight. Oopsie daisy. Page, insert page. Good, here we go. Is it the wrong place? Yeah, it's not the right place. So I want to change it to tangent, and because it's the only way you can deal with sine and cosine. So I'm going to be dividing here by cos theta. I'm also going to divide here by cos theta. If I do, I'm left with root 3 plus 3 times 1, which equals to 4. Sine over cos is nothing but tangent. So I'm going to write here tan theta. Now, let's get that tan theta, isolated. So you have got tan theta is equal to root 3 plus 3 all over 4. Now, I can actually go ahead and I can calculate. This is just a number. Don't be afraid of it. All right. So theta will be the inverse tangent of tan arctan of this whole story, whatever it is going to be. And I'm going to punch that into my calculator, and then I'm subsequently going to give you the full calculated display, and then I'm going to round it to 1 dp. First, problem number 1, this is in radians, so we're going to change it to degrees. Okay, select that, very important. Then arctan of the square root of root 3 plus, remember to go out there, all over 4. We go, close that, hit enter. All right, what do we get? We get 49 points, blah, blah, blah. I'm just going to place it over here. So that answer, therefore, to 1 dp, therefore, to 1 decimal place, it's going to be 49.8 degrees to 1 dp. That's our answer, okay, for 4 marks. Right, remember I am adding and putting certain values and certain things for you to know what to add. And also, do you see how I make use of my formulas? Because you're not Superman, you're gonna forget the formulas, and just make sure you go and pick from your note there. Well, we are supposed, it's another question on trigonometry. You should know that cosec of something is the same as 1 over sine of something. Okay? Then cot of something is the same as 1 over tan of something. In fact, cot theta is the same as cos theta over sine theta. Food for thought. We're going to use that most probably. Right. So I'm going to take, obviously you have to take, this is an identity. You need to prove that the left-hand side is identical to the right-hand side. It's not an equation. So I'm going to take the left-hand side. That's all that you can take anyway, which is cosec double angle of 2x minus the double angle of cot 2x. Good. And we're going to see how we can write it. Remember I said this is the same as 1 over sine 2x minus, then this is nothing but cos of 2x over sine of 2x. Can you see that the denominators are the same? So I can actually go ahead and combine them if I wish to. This is 1 minus cos 2x, and then you're gonna say everything over sine 2x. That's sine 2x. Maybe I need to go and get our formula from before, this stuff here, so you can see which one am I going to be picking. Let's see if I come to the right problem. No, I didn't copy it. Right. I'm interested in the double angle for cosine. It's not really here. But remember we've used it before, so I can still go and go get it since I'm not far from, finishing the paper. Um, it's quite a long paper in terms of explaining it, but it's not a difficult paper. So this is the part that I'm interested in here where we have our double angles. Okay, I'm going to copy that part. I'm going to go back and show you how to use the double angles in order for you to complete or to prove or verify that identity. Okay, so let's just get rid of you there. We can get rid of you over there. Let's paste what we're going to correct. Good. The double angle for this one, I am going to choose. Remember, we are supposed to prove tangent. So I'm not going to, and I have got a sine scenario underneath. That makes sense. So I'm going to choose the one where I have a sine here. So I'm going to choose this one. That's the same for the double angle. Good. So I have got 1 minus, in brackets now, in brackets, I have 1 minus 2 sine square x. No, but it's not x, it's double angle, okay? Is it? No, sorry, my goodness gracious. It becomes x because of that. That's how you convert it. All of this, obviously, we're going to put over. Here's another thing. Sine 2x can be written as nothing but 2 sine x cos x. If you were worried and say, where am I getting? There we go. We are very close, right? That numerator can be cleaned up a bit further. If you do that, you will have 1 minus, maybe I must just write it, 1 minus 1 plus 2 sine square x. You need to get rid of the double angles in order for you to prove the identity, okay? Right? You don't want to say equal to till you think it's an equation, which is not. So let's just insert a page at the wrong place again. Okay, let's say keep it something like that. And we insert a page. Let's see. Good. I wonder. Right. Now, what I'm going to be left, the 1 minus 1 is obviously 0, so I'm left with 2 sine square x, no more double angles, can you see that? Over 2 sine x, 2 sine x cos x. Right. Obviously, the 2's cancel, and the numerator can actually be written as sine x times sine x, and this can actually be written as the denominator, which is sine x multiplied by cos x. That makes sense to you? Well, sine x over sine x is nothing but 1, so this gives you 1, and you are left with sine x over cos x, and you should know that this is actually tan x, which is identical to the right hand side of what we needed to show. Does that make sense? Right, so all of that work, you need to be able to know a few things and use your formula sheet, or you should know them in order for you to prove that the left is identical to the right hand side. Okay, that brings me to question 7. So we are dealing with implicit differentiation, is it? Okay, right, so this again is something that you should know how to do, and I need to highlight that here I'm going to apply the product rule. That's why I'm highlighting them. So that's going to be, because I'm supposed to Find the gradient, that means I'm supposed to differentiate. So I'm going to use the product rule, and you know what the product rule entails, okay? If you need me to go grab it so you can see where it is, the product rule, yeah, the paper is quite long, I'm explaining. Let's find differentiation. Product rule is here, UV, okay, there we go. So let us take a snapshot. Good. Let's go back to our question. Our question. What is our question now? Here we go. I'm going to paste it somewhere over here, very close by. Just relaxed over there. Good, product rule. Right. In order for me to differentiate that, I'm going to go straight down. I'm going to say d by dx of all of that. So d by dx of 3e to the 3xy plus 2y squared is equal to d by dx of 15. You should know that the derivative of 15 is obviously going to be 0. Okay? Then when you have a y, don't forget to slap on dy dx there. So, product rule, keep the first dy dx, dy dx is equal to keep the first, right? And then differentiate the second. When you differentiate the second one, the first one is obviously 3e to the 3x, that's the first one. Then you're going to differentiate the second one, the y. The derivative of y is just 1, but please slap on dy dx there because it's differentiating with respect to y there. Then plus, now differentiate the first, and the way we differentiate the first is obviously you will be multiplying 3 times 3, which is 9. Then you have e to the 3x, that's how you differentiate that. And then obviously you are going to then keep the second one, all right, which is the y. That makes sense, right? And then plus the derivative of 2y squared is 4y, but you have to attach dy dx, and that is equal to 0. The derivative of 15 is equal to 0. Let's just clean it up and see what we have. We have 3e to the 3x dy dx plus 4y dy dx plus 9e3xy. I wonder, I'm just going to leave that y over there is equal to 0. So we need to make dy dx the subject of the formula, okay? So first of all, we have 3e to the 3x plus 4y, put it in brackets, slap the dy dx over there, and equals to negative 9e3xy. Good. Now we just have to divide all of that by that stuff over there. Therefore, dy dx is equal to negative 9e to the 3xy all over 3e to the 3x plus 4y. There we go. That is the answer. That's how you differentiate that. Alright, so please, I have done plenty of class on my channel on implicit differentiation. Just go through it and then you should be able to know how to do that. There is a B part to the question. Okay, it says find the value of y for which the tangent is parallel to the y-axis at the point where x equals to 0. Okay, here's the thing. When the tangent is parallel to the y-axis, that means it's a line that is like vertically like so. And the gradient of such lines, right, it's undefined. But in order for us to have any undefined scenario where you have a fraction it implies in this case that our fraction, which is our denominator, should equal to b to 0. That is how you can have a scenario like that. Okay, when you have a fraction like that. Remember when you are doing the gradient, let's say from grade 11, you delta y, delta x, exchanging y over exchanging x, right? And if you so happen to take two values of x, whatever, say here you get a value, let's say suppose it's 5, here you get 0. You are told that you can't, the gradient of this line doesn't exist, but this line is, the reason it's a vertical line, it's parallel to the y-axis. So that's why we are saying take the denominator, which is in this case 3e to the 3x plus 4y, let that equal to 0, because that's what it implies. The, 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 the denominator should equal to 0. And that's not all. They're also telling you find the y value where x is equal to 0. So where you have an x, you're typically going to substitute. Where you have e, you're probably going to have, most of the time, that x will be 0 in order for that e to sort of disappear, right? So that is 3 times 0 plus 4y is equal to 0. Remember, we're looking for the value of y. Now, anything raised to the power of 0, effectively, this becomes 1. So there's just going to be a 3. And then plus 4y is equal to 0. Now it becomes pretty much easy for you. So this becomes 4y is equal to negative 3. Therefore, y is negative 3 over 4. Okay, and that is the solution to this question. It says find the value of y. Good, we are going to question 8. Question 8, very important. So we are dealing with the harmonic curves here. Express 5 sine theta plus 12 cosine theta in that form. Now I hope you know that the value of r, we can just use Pythagoras. That is going to be 5 squared plus 12 squared. That is the value of r. And if you do that, that's 25 plus 144, that's 169. That's a square root of 169, which is equal to 13. Then you have a formula that you have tangent alpha, which in this case will be 12 over 5. That is tan alpha is equal to b over a, something that we expect you to be able to know. But I'll show you exactly how one works this out. So let's find that angle. And they are saying we should give that angle to 2 decimal places. And make sure your calculator, of course, here it's in degrees mode, so it's still in degrees mode. So arctan of 12 over 5, the tangent is the only one that can be improper, okay? 67.38, so it's 67.38 degrees to 2 decimal places. Eventually, I just want to show you how that comes about. Remember from compound angles, if you have a scenario like sine theta plus alpha, this is actually nothing but sine theta cos alpha plus, let's say, sine alpha cos theta. That's what it is, right? I'm just going to rewrite it slightly nicer. I'm going to say this is exactly like cos alpha sine theta. So I'm treating this cos alpha, you will see as a coefficient. Then I'm going to, this one is already like, the alpha is already in front. Now, from our scenario that we are given in the question, now this is the part that I'm interested in, the point that I want to make, okay? That's the part. 5 sine theta plus 12 cos theta. So I'm going to write that down here. So you have 5 sine theta plus 12 cos theta. Good. Can you see that? Now, if you have a look at that, whenever you have tangent, so tangent is most obviously, this is our A and that is our B. And from my formula that I was explaining to you, tangent is always B over A, so that is how I know it is 12 over 5, what I was using there, respectively. Okay? But of course, you can conclude because we haven't yet concluded. And eventually, at the end of the day, you can conclude this question. And I'm going to conclude and say, in this particular question, because all of this is just information, you say 5 sine theta, okay, plus 12 cos theta is equal to r, which was 13, okay, 13 sine, and then you had theta plus this angle 67.38 degrees, and that's the answer. Good. 3 marks. Hence, they are now saying solve the equation. So what was the equivalent equation? If you now look at the equivalent form, which is the harmonic part, okay, um, I'm going to say I'm not going to use this anymore because from my answer before I know that that is the same as 13. Let's remove that bracket. 13 sine theta was it plus 67.38. Okay, let's say that equals to 6.5, and we're looking for an angle that is between 0 and 360 degrees. Okay, so let's just isolate sine first. So that's sine theta plus 67.38. And if you have 6.5, you have 6.5 divided by 13, you get a half. So that half is that 6.5 divided by 13. Then what we are also going to get is we are going to get that all of this is going to be the inverse sine of a half. And you should know that the inverse sine of a half is 30 degrees. So you can use your calculator again. Make sure your calculator is in radian mode. Okay. Now, this is positive. In which quadrant is the sine positive? Well, you'll argue that sine is positive in quadrant 1 and quadrant 2. So in the first quadrant, I'm going to have theta plus 67.38. That generates, which equals to 30. That will give me a scenario where I'm going to get a negative answer. Does that make sense to you? And this negative answer is that theta is negative 37.38. And this is outside of our interval. It's outside of our domain. Now, for us to be able to find that, right, what that answer would be, because it's outside the domain, I'm going to talk about something. I'm going to say find the next coterminal angle, and I'll explain in a bit what coterminal angle is by adding, since this is degrees, I'm going to add 360 degrees. Okay, so in a nutshell, theta will equal to this negative 37.38. I'm going to add 360 degrees, and if I do that, I'm going to get 322.62 degrees, which is within our domain. Okay, then I'm going to explain what coterminal is in a minute. Let me just insert one page more. Wrong part. Page. Then in the second quadrant, remember in the second quadrant, sine is also positive. So I say theta plus 67.38, which in the second quadrant, you know, is 180 minus 30, which gives you 150. Let's see if this angle is within our range, which is from 0 to 360. then theta is going to be 150 minus 67.38. Of course, this one gives us that theta is equal to 82.62 degrees, which is also within our range. So at the end of the day, theta is equal to 82.6 to one decimal place, comma, what was that other answer, 322.6, so it's 322.6 degrees. These are the solution. Right, I just want to indicate a few things. What are coterminal angles? I'm just going to write it here so you can take note of it. Coterminal angles are angles in standard position that share, okay, that share the exact starting side and ending side. But they have different measures because they involve, because let's say because they involve extra rotation. That's why we are adding 360 rotations or things like spinning, either forward or backwards, forward or backwards. So, for example, if I say, for example, if you have, for example, you have 30 degrees and 390 degrees, okay? Because if there is 30 degrees over there, that is 30, then you can also find it starts there, it ends there. Can you see where it started and ended? So I will just show you an arrow. But I can also go with a different one. I can also say, well, I go all the way up to here, that's 360, right? Plus that extra 30, that is 390. So this one here is 390. So that's what we mean by that. So that is why I had to add 360, because that angle was not starting exactly from zero. It was somewhere at 67 point something, but I needed to say, let me go around and find out, where will that ending position be in terms of that. So if it's in degree, you are going to add or subtract 360 degrees depending on which direction you are going. Obviously, if you're adding and then you're going, is it clockwise? That means positive angles. If you go in negative direction, you'll be subtracting 360 and so on. Okay, with radians is 2 pi and so on. Right, so that's what I have done here for you to be able to see that I'm adding with that 360. There are many ways that you can obviously think of this, changing the domain, a new domain that guides you to see, but that is exactly for you to arrive there. One of the also things that I also say, it's always nice to be able to have a sketch in your head of any function for you to know exactly the number of solutions. Right. They say state the greatest values of 5 sine theta. Now remember, this here is nothing but 13 sine, was it 13 sine of theta? Was it alpha? It was alpha, right? Alpha. So let's go back. Um, all the way where we had theta plus 67.38. Okay. Sine of theta plus 67.38. Now here's my point. If this was a graph, right, that 13 there is your amplitude. Okay, so that graph obviously is going to be oscillating between what you have over there, starting obviously from here, going all the way up, coming down, and so on. So your R, because the sine graph oscillates between the normal, the sine graph, if you know the sine graph, it oscillates between 1 and -1. So the greatest value, if there's the greatest value is going to be 13 times 1, which is 13. And the least value is 13. I have -1 here because that's where you're going to have the least value, which is -13. So effectively, the solution to this is R, whatever your R is, positive and negative. Our R was 13. Because there was no constant added to this scenario. There was no 5 sine theta plus 12 cos theta plus some constant. Okay, that can affect the translation of the graph. So if you are saying state, from here you should definitely know that whatever this is as a function of sine, it will oscillate between 1 and -1, and that 13 just says that now it's going to affect the amplitude. Now it's going to sort of stretch it more, going up to 13 and then -13. That's it. Good. That brings me to my very last question. My very last question is obviously dealing with these type of curves called parametric curves that are also curves that you have to somehow find, you know, dy dx by differentiating them. Right. So they're saying find an expression in terms of dy dx. This is nothing to be afraid of. You simply just say, okay, dx dt, so I'm going to say dx dt over here, that is going to be 2t minus 4. That is if I do dx dt. Remember, just write my dx dt nicely. So that is dx dt. Then I'm just going to rewrite this as dt dx, or x must be under. So this is over 1, so that's going to be 1 all over 2t minus 4. Right. The next one, obviously, is going to be dy dt, which is this one here, and that is 3t squared minus 3. Now remember the chain rule, dy dx is equal to dy, and dx is over there. And what do you have in here? Here you have dt dt. It's like those dt's are cancelled. Can you see why I had to change my dt to dx? Okay, so dy dt from what we have is 3t squared minus 3 divided by, okay, because this one is all over, 2t minus 4. This here is dy dx. That's it. Okay. Of course, you can go ahead and take out the 3 there as a common factor on the numerator, or the 2 at the denominator, but it's not going to do much of a difference. All right, and plus you're in the exams, don't give yourself too much stress. This is perfectly fine. Now I'm going to use that here. Now let me just take a snapshot of that. Okay, and let me just paste it over here for 2 marks. What are they trying to say here? They are saying find the coordinates of the stationary point where t is equal to -1. Now just let that sink in a bit. You don't have a curve, so you can't make reference to any curve. Okay. So in order for me to sort of arrive at a conclusion, let's just say, let's first verify. And I'm doing that just as a teachable moment, okay? So let's verify, because once you are told that you find the coordinates, that's the x and y of the stationary point. Because of the word stationary point, this implies dy dx is equal to 0. Okay, so that's what I'm trying to just explain. So let's verify if this point t, if t equals -1, if it gives, you don't have to do this, but I'm just doing it so that you can understand why it works. If it gives a stationary point, and then find, and then, yeah, and then we are going to find the xy coordinates. I'm going to find the xy coordinates as the question demands us to do. Right. What do we know? A stationary point, okay, a stationary point occurs when dy dx is equal to 0. So we are going to substitute t equals to -1 into, check it out, the numerator, okay, of dy dx. That's what we're going to do. Because remember, the gradient, if the difference in y, the delta y, if that is 0, then the gradient is 0 of any function. So let's see if you do that. We should get the 0. So I have 3 minus 3. So I'm going to substitute the value of t, which is -1, and see what that gives me. Well, it gives me 0. Okay, so 3 in brackets, we have -1 all squared minus 3. That is 0. And so now if that is equal to 0, now I can actually go ahead and I can say, the way you will be solving it, you will say, this is now you solving it in the exam. That was just for me to explain this concept, why you should be solving it like this. So the way you solve this in the exam, remember the question is find the coordinates of stationary point, right? You are going to substitute um, t equals -1 into the equation, the two equations, into the equation. So first into the equation of x to find the x coordinate, the x coordinate, and subsequently we're going to do the same, right? So what was the equation? Now let's just go back, all the way back. These are the two equations I'm referring to. So I'm just going to copy them, take a snapshot, so that I don't have to come back to them again. So into that, I'm going to say, okay, this is going to be x is equal to, when I substitute t equals to -1 in here, right? If you do so, well, you have 1 plus 4, that is 5. So that's the x coordinate. Similarly, maybe I must just, again, include my page. This is the last page that I will insert. Similarly, you are going to substitute t equals -1 into the equation of y. Hopefully you can read my handwriting. I know it's, to find the y coordinate coordinate. Okay. So my y is this one over here. So that is going to be y equals to t cubed minus 3t. So y equals to cube minus 3t. And we are substituting -1 respectively. Okay, That's what we do. Substitute that. And what do we get? Well, that is negative 1 plus 3 is 3 minus that. That's going to give me 2. So my point is 5,2. Okay? So, therefore, the coordinate, I'll say coordinates, of the stationary point are 5,2. Right, so most of the other information is just information that I include, like to explain, for you to understand how to find, values and solutions and making deductions. And I hope this has been quite helpful um, as you attempt to finish your studies. You should be on the standby for paper one, and then of the same that was written recently in August by grade 11s in Erongo, I mean grade 12. So this is going to be, I'm going to be uploading this with, in the link below, you'll have a link that takes you to my channel where you can find the papers as well as the solution as I was working this one out. And then you have that, and plus then you can obviously also use the video if that is helpful at all to prepare for your studies. Okay, good luck with that.